Alright, we're picking up here with question 7, which deals with marginal revenue, and we're given a revenue function 20x minus x squared over 50, and so we want to determine the marginal revenue at a production level of 450 units, and then interpret those results. So when you hear marginal, you think derivative. This is a very simple function to differentiate. We just use the power rule, so we multiply the 2 around front. It cancels with the 2 in the denominator, which leaves 25, and anytime we have a linear term, we just preserve the coefficient and the x drops off. So our marginal revenue function is 20 minus x over 25, and we evaluate that marginal revenue function, that derivative of the revenue function, at 450. And so we divide 450 by 25. We put 450 here in for x, and 450 divided by 25 is 18, and so we subtract the 18 from 20, and that gives us 2. So our marginal revenue at x equals 450 units is 2. It's a positive 2, and so that means that revenue is increasing at the rate of $2 per unit produced at the production level of 450 units. In part B, we are asked to do the same thing, determine the marginal revenue at x equals 550 units at that production level. And so, once again, we evaluate the marginal revenue function, the derivative of the revenue, at 550. And so we got an x here, so we put a set of parentheses, and inside the parentheses we insert 550. We substitute 550 in there, and 550 divided by 25 is 22. So when we subtract 22 from 20, then our result is negative 2. And that is the marginal revenue at a production level of 550 units. So, at a production level of 550 units, revenue is decreasing. Because this is negative, revenue is decreasing at the rate of $2 per unit produced. Now, in question 8, we have a product rule. Have a product rule to differentiate. And so our first function in this product is pretty clearly x to the 4th, and our second function in this product is e to the x. And once again, I strongly urge you to make a table like this, identifying the f and the g and the derivative of the f and the derivative of the g, so that you can then substitute them into the formula of the product rule. So, first function is x to the 4th. Derivative is very simple. It's power rule. Bring the 4 around, subtract 1 from the 4, and so our derivative is 4x cubed. F prime of x, or d dx, dy dx, df dx, is 4x cubed. And now the derivative of e to the x is e to the x, so that's the simplest function that there is to differentiate. And we use the product rule, which is the derivative of f times g is f prime g plus f g prime. F prime is 4x cubed, g is e to the x, f is x to the 4th, g prime is e to the x, and so you're fine if you leave this in this form, or if you wanted to factor out the greatest common factor of these two, you could. The greatest common factor here is x cubed times e to the x, which leaves behind a 4 from this term and an x from this term. The next question, question 9, asks us to differentiate a quotient or a fraction using the quotient rule. And this is one of those cases where the the functions are so simple and the results are so simple that you can be easily fooled into thinking, really, is that all that there was to do? Well, yes, in this case, that is all that there was to do. So we identify the numerator, and I call it f of x. I think our book calls it t of x. Supposedly, I think that must symbolize top. And then they also identify the denominator as b of x, bottom, but I identify them as f of x and g of x. So our f of x is just x, and our g of x is 2 minus x, and that makes the derivatives very simple. Derivative of x is just 1. In differentiating the g of x, the 2 is a constant and vanishes, and the derivative of negative x is just negative 1, and so now we substitute these four expressions into the rule, which is f prime g minus f g prime. So what's f prime? F prime is 1, and g is 2 minus x. So that's the first expression in the numerator. And then f is just x, f of x is x, and g prime is negative 1. So we have 1 times 2 minus x, which is just 2 minus x, and negative x times negative 1, which is positive x, and then the x's, negative x and positive x, cancel additively in the numerator, so our numerator is just 2. And for the denominator, all we have to do is put some parentheses around our g of x and raise it to the second power. And so that is our final answer. Now, if you wanted to, and there would be no real reason to do so, but if you wanted to, you could expand this 2 minus x out. You could multiply it out if you wanted to. But this is perfectly good. That's a perfectly good answer right there. All right, and the last question here is the chain rule, or involves the use of the chain rule. And so to differentiate using the chain rule, we identify what the outer function is, as well as what's inside. And so it's pretty clear that what the outer function is this expression raised to the 4th power. So we take the derivative of that, and we leave what's inside alone for the time being. So we bring the 4 around front here, use the power rule, bring the 4 around front, so there it is. Then we subtract 1 from the 4, so this becomes a cube, a 3, and we leave this inside alone for the moment. Then we differentiate what's inside here. Well, the derivative of what's inside is 1, because the derivative of x is just 1. And then we keep this constant multiple, negative 2, times the derivative of natural log of x, which is 1 over x. So 2 times 1 over x is 2 over x. And then the last thing that we do is realize that these are 3 expressions multiplied together. That means that they can be ordered in whichever way you see fit. And I have taken the 4 and distributed it inside these parentheses to simplify a bit. 4 times 1 is 4. 4 times 2 is 8. So this is 4 minus 8 over x. You cannot distribute the 4 into these parentheses because they are raised to the 3rd power. If you very foolishly expanded this and multiplied x times 2 times the natural log of x, times, in parentheses, x times 2, now minus 2 times the natural log of x, times, in parentheses, x minus 2 times the natural log of x. Then you could distribute the 4, but what a mess you would have. So there is no point to that. In the bonus, we have 6 conditions that we are asked to meet. And to answer this question, I think the best way to go about it is one step at a time. And for instance, here it says the value of the function at 2 is 0. So what that would mean is that at 2, you would want to put a filled in black point here, a filled in point here, and then just go around and do various other things to show each of these conditions.